Okay. Okay, so we're looking at simplifying exponents. Okay, so simplifying exponents here. I'm going to write down a couple rules that are going to apply to this. So one of the rules, it looks like it applies, but it doesn't. It just has to do with multiplying exponents with the same base. So they'll sometimes write the rule like this. If you have a to the x times a to the y, you can simplify by writing it as one base and just writing x plus y. Okay, whatever those two exponents are. The same concept holds for division. A to the x over a to the y. You can simplify again, you write the same base, but this time it's x subtract y. Okay, we'll add one more because it's going to come in handy on the next one after this. If we have a to the x and then all of that is to the power of y, you still write it as one base, but in this case you just multiply the two exponents. Those are the major ones. A to the 0 is 1, and then if it's a negative, do you know to invert it? Is that something you're aware of? Yeah, I just make the reciprocal of it. Perfect. Okay, so these are the major ones when it comes to simplifying. But key here, though, is just making sure that you can recognize what the same base is. So you'll notice in both of these, okay, the base is the same. That's actually really important for what we're going to do. So when we go here, you'll look at x. We have x and we have x. But we don't have x beside it. We have a different variable. So we actually are unable to use the very first rule that we have. We can't use this rule here because there is no multiplication between variables that have the same base. Okay, because x and y don't have the same base, so I actually can't go across the numerator here. I can only go up and down or division. So I'm going to put little sets of brackets that'll help us kind of keep track of what it is we're focusing on. So we have x to the 0.5 over x. Whoops, that's not an x. X to the 0.3. And we can actually split it like this because it's still multiplication. Y to the 1.8 over y to the 2.5. So all I did was I split it up because if we were to multiply these fractions, we just do the top by the top and the bottom by the bottom, and we'd actually end up right back here. This is not a step that's necessary. It just helps us make sense and makes it a little easier for us to look at, okay? I did not need to rewrite a here. That was not important. Okay, so let's move this up a little. So now what it is, it's just the rule of division here. So we write the same base. So for instance, I have x, and I'm just going to subtract the top exponent from the bottom exponent, whatever it is. So I'm going to rewrite these two. We'll rewrite the x. X is to the power of 0.5, subtract 0.3. Okay, and I'll put a little set of brackets. That's just dealing with the first set of brackets. The second set of brackets is base y, 1.8, subtract 2.5. We'll put a set of brackets. Those these square brackets, they're just representing these little brackets we made here just so we can see the difference. Really, again, we don't need them, and we can do it in the future without them, but I just want to make sure we're able to separate these. Now that we have that, it's just subtraction. So in this case, we're going to get x to the 0.2 and y to the negative 0.7, I think. Yep. And we don't need that set of brackets, so we can actually just write them beside each other. X to the 0.2, y to the negative 0.7. Now there's a question, positive exponents. So sometimes they'll tell you this, you must write it as a positive exponent. I mean, there's no mathematical rule saying you can't have negative exponents, but they just want to make sure you can deal with that. So what it means is this one has to turn into its reciprocal. Okay, so that's what we talked about briefly at the beginning. So this will still stay as x to the 0.2. I'll put this as a reciprocal, 1 over y to the 0.7. And again, this is technically multiplication, okay? I can actually write a denominator over x, and the denominator is just 1. Nothing changes when I do that. And now I can carry out fraction multiplication. So when I carry out the fraction multiplication, the top times the top will just end up with x to the 0.2. And the bottom times the bottom will just end up with y to the 0.7. So I did a lot of extra steps in there that you don't normally have to do. Let's zoom out a bit and see. Try to look at this in one spot here. Okay. Quite a few, like these extra brackets here, this extra step of multiplication, you can probably skip a lot of that. But I tried to do every single step, so you really got a feel for how much is actually going on in this question. So what we'll do next is we'll jump to the next page. This one's a little tougher. Let's get it in view here. So this one here, have they talked about how to write a radical exponent? For instance, a to the second root. So if there's nothing there, it's implied the number 2 is there, is actually equal to the base to the power of a half. Okay? If it's the third root of a, that's actually equal to a to the power of 1/3. We can write it as a fractional exponent. Okay? That comes in really handy with these powers, knowing that. So if there's nothing here, this is one of the rare cases we don't assume a 1 or a 0. We actually assume the number 2. Okay? Whoops, I kind of put it out of the picture there, I realized. We assume there's a number 2 when there's nothing written here. So it's a square root, okay? Any other root, third root, fourth root, fifth root, they have to write the number in for us to know it, okay? So what I'm going to do is I'm actually going to take this out of the radical, so out of a root, and we're going to turn it into a fractional. Oh, can you still hear me?
Yeah.
Okay, my headphones. Okay, there you go. We'll put it as a fractional exponent. It'll make this part a little easier. So we're going to rewrite this. C is equal to x squared y to the power of 4, and then in a set of brackets we write a half all over x to the power of -2, y to the power of 3 to the power of -1. So what's handy here now, if we zoom down, is remember that rule on the previous page? We had this rule here. When we have exponents that are multiplied by or to the powers of each other, we just multiply those two exponents. So we go over here, this is actually being multiplied by both of these. So we're going to multiply this half by 4 and this half by 2. And we're going to multiply the -1 by 3 and the -1 by -2. So we're going to bring it in for multiplication, okay? So we'll get x to the 2 times a half. I'm going to write it out. I'm sure this is math you can probably do in your head in one step, but we're going to write it out just for our notes, so that if we ever have to revert to our notes, we know what's happening. X to the power of -2 times -1, and y to the power of 3 times -1. Okay? We continue. We're just going to carry out that multiplication here. So we'll get x. 2 times a half is just 1. And for y, 4 times a half is just the number 2. X, -2 times -1 is +2. And 3 times -1 gives us -3. So all of our exponents are almost okay. I mean, we don't have to write the 1 in, but this one's negative, okay? We also have to carry out our division. We still have this piece of it because we have two bases that are the same. So just like in the previous question, we're going to carry out a little bit of division here. What I'll do is I'll jump back up to save some space on this page. Yeah, we have some room there. I'll draw with an arrow. I'll just come way back up here. So I'm going to rewrite it. I'm just going to rewrite it here so we have more space on the page for notes. X to the y, 2 over x squared, y to the -3. Okay, we can rewrite these. I'm going to rewrite the x. X base, technically there's a 1 there, so it's 1 subtract 2. And for y, it's 2 subtract -3. X, 1 subtract 2 gives us x to the, should be writing equal signs here, sorry. There we go. Becomes -1. And y, this actually becomes like adding 3, so it becomes y to the power of 5. So then our last step here is make that x positive. Essentially, we just flip it to the bottom. We would end up with y to the 5th over x to the power of 1, but we don't have to write to the power of 1. And that would actually be your final answer in this question here. Yeah, so I know we went through that quickly, but that's the general idea of simplifying exponent functions.